With that brief introduction, let's quickly get to the heart of the matter and compute the spectrum of our EEG data. We'll start here by pressing forward and presenting all of the formulas and MATLAB code that we need to compute the spectrum. Throughout the rest of this module, we'll then circle back and consider each step of our analysis in more detail. Let's begin with the mathematical formula for the discrete time Fourier transform of our data. This formula is pretty complicated. At this point, we won't dig into all of the details necessary to understand this formula. Instead, we'll introduce some of the notation, and then throughout the rest of this module, we'll break down the individual pieces. We observe that this expression is the product of two quantities. Our data, x sub n, where little n indicates the time index, multiplied by a complex exponential. This complex exponential is a function of two variables, the discrete frequency f sub j, and the time axis t sub n. Let's not get into the details of these two variables here. We'll do that throughout the rest of the module. To provide some intuition, let's simply state that this expression takes our data, x sub n, and multiplies it by sinusoids oscillating at different frequencies. The result is a new quantity, x sub j, our signal as a function of frequency fj rather than time, tn. This is the Fourier transform of our data. The spectrum is then the product of the Fourier transform of x with its complex conjugate. Note that here we indicate complex conjugate with the superscript, asterisk. This product is then scaled by a constant, 2 delta squared over big T, where again, delta is our sampling interval and big T is the total duration of the recording. The units of the spectrum are, in our case, microvolts squared per hertz. This expression represents the spectrum of our EEG data x. It's pretty complicated, but don't worry. We'll dig into all of the pieces as we complete this module.